NASA's press conference on November 19, 2025, marked a significant moment in humanity's ongoing observation of objects that originate beyond our own solar system. The agency gathered scientists, media, and the public to present newly released images and findings related to Comet 3 I/Atlas, only the third confirmed interstellar object ever detected passing through our cosmic neighborhood. From the very beginning of the briefing, Associate Administrator Amit Kshatriya addressed a wave of speculation that had been circulating widely across social media platforms. With calm clarity, he reassured the public that 3 I/Atlas is a natural celestial object, a comet from another star system, and not anything connected to extraterrestrial life or artificial technology. This reassurance was an important step in grounding public understanding in scientific evidence, especially at a time when rare astronomical events can easily spark sensational interpretations. Comet 3 I/Atlas has drawn extraordinary attention precisely because of its rarity. Before it, only 2 interstellar visitors had been confirmed. 1 I/Oumuamua in 2017 and 2 I/Borisov in 2019. Each of these objects provided scientists with invaluable insights into the composition and behavior of material formed around other stars. The discovery of 3 I/Atlas added a new chapter to this short but fascinating list. Detected as it entered the inner solar system, the comet was quickly identified as traveling on a hyperbolic trajectory, meaning it was not gravitationally bound to the Sun and would eventually leave the solar system forever. This trajectory alone confirmed its interstellar origin, setting it apart from comets that originate in the distant Oort cloud surrounding our own system. Once its interstellar nature was confirmed, NASA and its international partners acted swiftly. Numerous spacecraft and space-based observatories were redirected to observe 3 I/Atlas during its brief visit. Among these, the Mars Reconnaissance Orbiter achieved the closest view of the comet. On October 2, 2025, when 3 I/Atlas was approximately 19 million miles from Mars, the orbiter captured images that revealed valuable details about the comet's structure and activity. Observing an interstellar object from Mars' orbit provided a unique vantage point, allowing scientists to study the comet under conditions different from those available near Earth. These observations contributed to a better understanding of how such objects behave when exposed to solar radiation after spending countless years in the cold depths of interstellar space. The comet's closest approach to the Sun occurred on October 29, 2025, at precisely 11:47 Universal Time Coordinated. At that moment, 3 I/Atlas was about 1.36 astronomical units from the Sun, a distance roughly equivalent to 126 million miles. While this might seem far in everyday terms, astronomically it was close enough for the Sun's heat and radiation to significantly affect the comet. Like many comets, 3 I/Atlas responded to this increased solar energy by becoming more active. Ices that had remained frozen for eons began to sublimate, releasing gas and dust that formed a glowing coma around the nucleus and extended into a visible tail. This transformation offered compelling evidence that, despite its exotic origin, the comet behaves in familiar ways, governed by the same physical laws that shape comets born within our own solar system. Professional astronomers were not alone in capturing this moment. Renowned astrophotographers Michael Yeager, Gerald Riemann, and Enrico Prosperi also turned their telescopes toward the comet as it emerged from its closest passage near the Sun. Their images, shared through the ICQ Comet Observations Facebook page, quickly gained attention for their clarity and artistic beauty. These photographs showed the comet's evolving structure, highlighting how its close encounter with the Sun had altered its appearance. The bright halo surrounding the nucleus and the elongated tail told a visual story of heat, motion, and transformation. Such contributions from the astrophotography community play an important role in modern astronomy, bridging the gap between professional research and public engagement, and reminding us that meaningful observations can come from dedicated observers around the world. As 3 I/Atlas continues its journey, it is now on a path that will carry it back out of the solar system, never to return. However, before it departs entirely, it will make its closest approach to Earth around December 19, 2025. At that time, it will be about 1.8 astronomical units away, or roughly 168 million miles. While this distance ensures that the comet poses no threat to our planet, it also means that it will never be visible to the naked eye. Those hoping to glimpse this rare interstellar visitor will need proper equipment and patience. Astronomers estimate that at least an 8-inch telescope will be required, with larger instruments offering better chances of seeing the comet's faint details. The best opportunity for observation is expected to be in late November, when 3I/Atlas remains in the eastern pre-dawn sky. For amateur astronomers, this presents a special challenge and a unique reward. Observing an object that originated around another star is not an everyday experience, and for many, it will be a once-in-a-lifetime event. Telescope gatherings and observation sessions have already been discussed within astronomy clubs, turning the comet's passage into a shared communal experience. Even though it will appear as a faint smudge rather than a dramatic spectacle, the knowledge of what it represents adds profound meaning to the observation. Adding further scientific value to this event, the European Space Agency's Jupiter Icy Moons Explorer, known as JWST, has also been observing Comet 3I/Atlas between November 2nd and November 25th, 2025. JWST, though primarily designed to study Jupiter and its icy moons, is equipped with sensitive instruments capable of analyzing distant objects. By observing the comet shortly after its closest approach to the Sun, JWST has a rare opportunity to study 3I/Atlas while it is still highly active. Scientists expect these observations to reveal details about the composition of the comet's gas and dust, offering clues about the conditions present in the star system where it originally formed. The study of interstellar objects like 3I/Atlas holds immense scientific importance. These visitors serve as natural probes, carrying information from distant regions of the galaxy directly into our observational reach. By analyzing their composition, structure, and behavior, scientists can compare them with objects formed in our own solar system. Similarities can suggest common processes of planet and comet formation across the galaxy, while differences may point to variations in chemical environments or evolutionary histories. Each interstellar object thus becomes a messenger, offering insights into worlds we may never directly see. Beyond the science, the public response to 3I/Atlas reflects a deep and enduring fascination with the unknown. The rapid spread of speculation about extraterrestrial origins, while scientifically unfounded, highlights how strongly such discoveries capture the imagination. NASA's transparent communication and emphasis on evidence-based conclusions play a crucial role in guiding that curiosity toward understanding rather than fear or misinformation. Events like this press conference demonstrate the importance of clear scientific outreach in an age where information spreads faster than ever before. As Comet 3I/Atlas fades into the distance, it leaves behind more than just data and images. It leaves a sense of connection to the broader galaxy and a reminder that our solar system is not isolated, but part of a dynamic, interconnected universe. Objects from other stars can and do pass through our cosmic neighborhood, offering brief opportunities to learn from them. While 3I/Atlas will soon disappear from view, the knowledge gained from its passage will remain, shaping future research and preparing scientists for the next interstellar visitor, whenever it may arrive.